Okay, now we're going to do a t-test and a chi-squared test. So for the t-test, we have that women will enjoy romantic movies more than men as hypothesis 1, and hypothesis 2 is only children will have more friends than people with siblings. Okay, so this is the first time we're going to use this equation style format in R. Usually when you want to put an equation into something, it is in the format of Y, and then you use this little squiggly tilde, which is in the, if you hit shift and then hit the upper left hand corner of your keyboard, it'll give you that little symbol. And then you add in the X variables, and you can add them together or multiply them together to get interaction effects there. So for our t-test, we have romantic movies as the Y variable. It is our dependent variable. And then gender is our grouping variable. It's our X variable, so it's going to go after the little tilde. And then you do a comma, data equals, and then we just happen to call our data data, so we put data equals data. But if you called your data something different, then you would put something else in right here. But we have data, so that's good. Cohen's d is the effect size for a t-test, and everything that goes in the parentheses is the same there. So let's go ahead and run this. And we'll interpret our results. Here's our t-value, which you would normally report, and then the degrees of freedom, which is indicative of how many people are in this sample. And then we have our p-value here, 2.2 times 10 to the negative 16. So again, very, very small. It's 0.00015 times 2, so definitely less than 0.05. Which means that there are significant differences between females and males in how much they like movies. And then you can look down here to the means to see who liked romantic movies more. So females had a higher, significantly higher rating of romantic movies than men, meaning that they liked romantic movies more. And then this is our Cohen's d effect size. This was a very large effect. So females very strongly preferred romantic movies more than males did there. Okay, so now we're going to do this for hypothesis 2. I'm just going to, again, copy the code. And then the variables we're going to do is only child and friends. Okay, so friends is our dependent variable. It's the continuous variable. And then only child was the name of our dichotomous variable. And if you don't remember exactly what the variable you're working with is called, you can hit this little blue arrow right here next to data, and it'll give you a list of the variables that are in that data set. So then you can pull up, oh, okay, only child has a capital O and a lowercase c, and make sure that you get it in there correctly. Okay, let's go ahead and run this. So our t-value is negative this time. We have a small negative t-value. And then our p-value is greater than 0.05. It's quite large, 0.57. So there was no significant difference here. As you can see by the means, only children have about the same amount of friends as people who have siblings. Everyone has about 3.3 some friends. And of course, a very small effect because there is no effect here. Okay, so did we reject the null hypotheses? For the first one, we did. Females rated themselves as liking romantic movies more than men. And then for hypothesis 2, we failed to reject the null. only children had a similar number of friends as children with siblings. Okay, now the chi-squared test. We predicted that only children will be left-handed more than children with siblings, and that males drink a lot and drink socially more than females. So for this one, it doesn't have the formula format, so you're just going to tag the two variables using data, $, and then the variable name. We'll go ahead and run this first code here. And we see that the p-value is 1. It's as high as it can possibly be. This is not significant at all, an extremely low effect size. So only children, whether you're an only child or you have siblings, is not related at all to handedness, which we might actually expect. Okay, so for hypothesis 1, we failed to reject the null. We found that only children and children with siblings were not different in handedness. Okay, now for hypothesis 2. We have alcohol and gender. And you'll notice when we run this, that it will tell us that there are differences between these groups. So the different genders are different in the frequencies with which they drink alcohol, but it doesn't tell you which ones are different from which. So this p-value is less than 0.05, which means that there is differences between the genders in how much they drink alcohol, your chi-squared value, and your degrees of freedom. This is your effect size value. So if you look up here for a Kramer's V effect size, this is a relatively small effect size. But we might want to go further here to really answer our hypothesis and say, okay, we know that there are differences here, but what are the differences? And so to do that, we're going to create a table of these variables. I'm just going to call it table right here. You can call it whatever you want though. And then I'm going to run a table function, and I'm going to use these two variables. And then I'm going to print the table function, and I'm also going to run a chi-squared mult comparison. So CHISQ.MULTCOMP. And I'm going to tag this table in it, and then I'm going to do p.method, and I'm going to do a lowercase FDR, which is going to control for the fact that we're doing multiple comparisons here. So let's go ahead and run all of this code. Okay, so now we can see the chi-squared value that shows that there are differences between the two groups. This is the printout of the table we made, so you can see that 68 females were never drinkers and 55 males were never drinkers. 418 females were social drinkers and 237 males were social drinkers, and 104 females were heavy drinkers and 117 males were heavy drinkers. And then we got a pairwise comparison table, which tells us if these numbers are significantly different in their proportions than the other ones. So we are interested in if 68 is different than 55. This p-value is greater than 0.05, so they are not different. Is 418 different than 237? If you look here, you get 2.9 times 10 to the negative 12. So that's much lower than 0.05. So these two numbers are significantly different. Females are social drinkers more than males. And then 104 and 117, we're going to look at 104 and 117. That's this number right here, and that is greater than 0.05. So those two numbers are not different than each other. So we rejected the null hypothesis, but we didn't confirm our alternate hypothesis. What we actually found was that while females and males are never and heavy drinkers at similar rates, females drink more socially than males. And these are based on proportions, so it's not just because the female sample size was bigger. If the proportions were the same, then you would expect for the females to be higher in social drinking, not drinking, and heavy drinking, which is not the case. It seems like all of the extra females are social drinkers, so there is somewhat of a curved relationship there. Okay.